surface of the wedge of air and the back surface. Now, at the same time, the glass plate, which is a backup for the front plate, is itself ground very accurately so that its front and back faces are parallel. Now, the interference pattern from reflection from the front and back faces of the glass plate is different in nature from that pattern that comes from a thin wedge of air. Now, in order to see the interference pattern in any case, it is necessary to have two things: one, monochromatic light, and two, an extended source of light. We have a sodium vapor lamp here, which provides an extended source over the window here, which is of the order of a few square inches of area. Now, ideally, to see the interference pattern, you would like to have the source making an angle normal to the glass plate. So in order to see these effects as strongly as possible, we want to try to achieve that condition. We have to keep it at a little bit of an angle so that we can see past the light source and see the fringes. Now, we have set up here a TV camera which is focused on the image of the interference pattern from the glass plate, and we'll look at that first, and then we'll move in and see the interference pattern from the wedge of air. If we could turn the lights off here in order to see this clearly. Now you will notice, must turn the lamp on here. We have to keep the lamp cool in order to keep a sharp interference pattern in this effect here. So now you see in the screen on the right-hand side a series of light and dark fringes, rather faintly. These are the interference fringes, which are parts of circles which are centered toward the upper left-hand corner of the screen. And these are the interference fringes formed by the glass plate. Now we'll move the camera back and start to focus on the lower front glass plate. You notice that the fringes go out of focus, and that is because the camera was focused at infinity. And now when we focus at a finite distance away, those fringes no longer appear, but we get the new set of fringes which come from the, there, we're now in sharp focus, and we get the new set coming from the lower glass plate. If you notice, the fringe pattern is extremely sensitive to the touch. A slight touch will shift it across the screen there, and the motion there is the order of a few wavelengths of light in order to produce such an effect. Now, the way you can tell the difference between these two patterns, your eye can, if you look at them, can appear to be focused on both of them. You're not going to look to a TV camera, so in the actual setup, we'll have to set up a telescope, and then you'll be able to focus on these fringe patterns through the telescope. Now, with the telescope all the way in, we're focused at infinity, so you should be able to look down through the eyepiece of the telescope and see a series of circular fringes corresponding to the interference pattern from the thick glass plate. Now, and a thing to note about it also is that since the interference pattern comes effectively from an image at infinity, that you can move the glass plate back and forth, and that pattern will not go out of focus because the telescope is already focused at infinity. Now then, you can pull the telescope out and focus on the front glass plate, and you see that when you focus on that plate, that you no longer see the interference pattern from the back glass plate, but you're now seeing the interference pattern from the wedge of air. And another thing to note that is if you're looking at that interference pattern from the wedge of air and move the source backwards or forwards, the focus will, the image of the interference pattern will go out of focus because it is at a finite distance away rather than at infinity. So this experiment then contrasts these two forms of thin film interference very effectively, And that's about all there is to this experiment. This is an experiment to illustrate the nature of interference by reflection in thin films. We have a simple setup here to show the nature of this interference pattern for a thin wedge of air which is formed by a glass plate taped to a backing plate, and the pattern will come by interference between reflections off the front surface